Welcome. Today we'll start a new topic, pipelining. And in pipelining, basically there are two important pipelining techniques. One is called instructions pipeline and another is called arithmetic pipeline. Today, at first we'll start what is the concept of instructions pipelining. Now suppose here we consider the hardware circuits that will be involved to execute a instruction. Suppose within the CPU, a instruction entered and a instruction will be executed. The whole instruction will be executed through all these hardware circuits, and ultimately we'll get the instruction executed in this stage. So now if you consider the whole process as a single unit, then the instruction will execute within this hardware, and executing all these steps in some cycles, clock cycles, the instruction will be executed. Suppose it may take 4 clock cycle to execute the whole instruction, or it may take 5 clock cycle, or it may take 3 clock cycle to execute the whole instruction. That is called CPI, clock cycle per instruction. Now in pipelining, the concept is that the whole procedure of instruction execute will be divided into some smaller stages. Suppose the whole instruction execution is divided here into 5 stages. The first stage is instruction fetch, and for instruction fetch, this particular hardware will be involved. And second stage, this is the first stage. The second stage, that is the instruction decode. So that's mean this is the hardware portion that will be used for the instruction decode. And the third stage, that is the instruction execution. This is that particular hardware section to instruction execution. And then the fourth stage is memory access, and these are the hardware that will be involved for this particular task. And last one stage, that is called write back instruction, and this is the hardware that will be executed, that will be used for execution of the last stage. That's mean whole instruction execution process is divided into 5 stage. So that's why it's called the 5-stage pipelining process. And for simplification, we'll say all these stage in this name. We'll call all these stages by this name. So the first stage is IF, instruction fetch. Second stage ID, instruction decode. Third stage instruction execution, and operand fetch, instruction execution, and write back. This is the instruction execution and memory. So this will be the instruction execution, this will be EX, and this will be MEM. MEM. This will be MEM. MEM, not EX. EX will be this. EX will be this. EX will be this, and this will be MEM. So the 5 stage is IF stage, IDS stage, EX stage, MEM stage, and write back stage. So these are the 5 stage. So now let's see how using this 5 stage the pipelining and non-pipelining process is executed. Suppose all these are the clock pulse. First clock pulse, second clock pulse, third clock pulse, fourth clock pulse. This is the clock pulse. Suppose for a non-pipelining processor, the first instruction is entered within the system. So in the first clock pulse, the instruction phase stage is executed. In the second clock pulse, the decode stage of the first instruction is executed. Then instruction execution stage is executed. The memory access stage is executed, and write back stage is executed. That's mean every instruction will be executed through this 5 stage. So the first instruction will be executed after 1, 2, 3, 4, 5 clock cycle. So after 5 clock cycle, the first instruction will be executed. So now if you consider the non-pipeline procedure, then the second instruction, the instruction fetch of the second instruction should be start from this 6 clock pulse. 6 clock pulse, that means the instruction fetch of the second instruction should be start in the 6 clock pulse. Then the instruction decode will be start in the 7 clock pulse, and then the execution will be start in the 8 clock pulse, and the memory execution will be start in the 9, and the write back will be start in the 10th. So that's mean in a non-pipeline procedure, if we execute 2 instruction one after another serially, then it will take 10 clock pulse to execute just 2 instruction. That is for non-pipelining. But in the pipeline system, what happens when the first instruction will enter into the decode stage, then the second instruction will be entered into the instruction phase stage. Then in the third clock pulse, when the first instruction will execute the instruction execution stage, second instruction will enter into the decode stage, and the third instruction will enter into the instruction phase stage. In the fourth clock pulse, the first instruction will enter into the memory access stage. Second instruction will be executed in the instruction execution stage. Third instruction will be entered into the instruction decoder stage, and fourth instruction will be entered into the instruction phase stage. In the fifth clock pulse, the first instruction will be entered into the instruction write back stage, the second instruction into the memory access, third instruction in the instruction execution stage, fourth instruction will be entered into the instruction decoder stage, and the fifth instruction will be entered into the instruction phase stage. That's mean in a particular clock pulse, the five different instruction will be executed by the 5 different components of the instruction of the hardware of the 5 stage. There are 5 stage, total 5 stage, 1, 2, 3, 4, 5, and 5 instruction will be entered into the 5 stage. So in the 6 clock pulse, from the 6 clock pulse, the first instruction will get the first instruction to be executed. In the 6 clock pulse, we'll get the second instruction to be executed. Second instruction will be executed, and in the 7th clock pulse, the third instruction will be executed. That's mean from now on, in every clock pulse, one instruction will be executed. So in the non-pipelining process, after 10 clock cycle, only 2 instruction will be executed. But here, after 5th clock pulse, in every clock pulse, a new instruction will be executed. So this way, the throughput of the processor will be increased. Now, after 5th clock pulse, the throughput of the system will be throughput of the system will be 1 instruction per cycle. That means after 5th clock pulse, every 1 instruction will be executed in every clock cycle. So here the throughput will be 1. Otherwise, in a non-pipelining processor, the throughput was 5. That's mean in every 5 clock cycle, a instruction will be executed. That's mean in 10 clock cycle, 2 instruction will be executed. In 15 clock cycle, 3 instruction will be executed. So throughput in that case, the throughput will be 5. But here, if we use the pipelining system, pipeline hardware, then it will be throughput will be 1. So that's why the first 4 cycle will be used for the pipeline fill up. Then after that, one instruction completes in every cycle. So the first what does it mean? This means after 5th clock pulse, up to 5th clock pulse, no instruction will be executed. After 5th clock pulse, in every clock cycle, a one instruction will be completed. So now we'll see some terminology related with the pipelining system. In the pipelining system, that is called the all these 5 hardware components are called the stages. So here we have 5 stages: instruction fetch stage, instruction decode stage, instruction execution stage, memory stage, and write back stage. So it will be this this will be the execution stage, this will be the execution stage, and this will be memory access stage. This will be memory access stage. This will be memory access stage. So all these are called the stages. Now that's why this is called the 5-stage pipeline. Otherwise, it also can call the depth of the pipeline is 5. Assume that the every stage will take 1 clock cycle. Every stage will take 1 clock cycle to execution. Now, the very important terminology that we have to understand about pipelining, that is called the speed up. So how we calculate the speed up of this pipeline system? To calculate the speed up, we have to calculate the time in non-pipeline procedure for execution n number of instruction, as well as we'll divide that time by the time used in the pipeline procedure. So by calculating this, we can find the speed up of the a pipelining system. So now let's see how we can calculate the speed up of the pipeline system. For 5-stage pipeline taking 1 cycle per stage, let us compute the speed up over a non-pipeline procedure that takes 5 cycles for every instruction. So in the 5-stage pipelining, we will calculate the pipelining, the speed up of the pipeline. So this will be the execution, and this will be the memory access. Calculate how much time each of these processor take. Each of this means we have to calculate the time for the non-pipelining system to execute n instruction, as well as we have to calculate the time for the pipeline system to execute the n instruction. So in non-pipeline procedure, it will take 5n cycle time to execute n instruction. In the pipeline procedure, to execute n instruction, at first 4 cycle, within the 4 cycle there will be no instruction to be executed. After 4 cycle, in every clock cycle, a individual instruction will be executed. So that's why the total time will be 4 plus n cycles to execute the n number of instruction. So to execute n number of instruction in non-pipeline, it will take 5n cycle, and to execute n instruction in the pipeline system, it will take 4 plus n cycles. So speed up calculation will be the time for the non-pipeline system, that is the 5n, and time for the pipeline system. So if we take n as a large number, suppose it's the millions of instruction, then we can say 4 plus n will be equals to n. 4 plus n will be, so we can ignore the 4 because n is a very huge large number. So then this value will be equal to 5. That's why the speed up of this 5-stage pipeline will be 5. Speed up of this system is 5. Now what is this 5? This 5 is nothing but the number of stage. So here this 5 is the number of stage This is the 5-stage pipeline, number of stages. So if in a pipeline system, if the number of stages is P, then what will be the speed up? Speed up will be, the P will be the speed up of that pipelining system. That's why a pipeline with P stage would give a speed up of P. So for an 5-stage pipeline, it will be 4-stage pipeline, it will be 4 P-stage pipeline, the speed up will be P. Thank you.